Hello everyone, welcome to AB Math Solution. Anushya here. So in this video we are going to see what is differentiation and why we are using differentiation in our daily life. So let us consider a square of side length x, and if you find the area for this side length x, it will be x square, and I'm equating that area to y. Okay, so this is the area of the square. So I have considered the area as y, and if the side length is x, if you use the formula to find it, it is x square. So y is equal to x square. So what if I extend the length? So if I extend the length, there is a change in length. The change in length is denoted as dx. Okay, if I extend the length, my area also will be increased. So I'm going to consider the change in area as dy. Okay, change in area as dy. We are considering the change in length as dx and change in area as dy. Okay, so we are going to split this area into three parts. So 1, 2, and 3. So there are three parts. We are going to divide this area into three parts. So we will get a rectangle of side length x and dx. In the second part, the side length is dx in all sides. And in the third part, the side length is x and dx. So when you find the area for these three parts, it would be x dx, and small one is a square, so dx square. Since this area length is very small, dx is equal to 0.01, and when you find the area, it is 0.0001, we can neglect this. We can find the area only for this two rectangles. So what will be the total area? So total change in area is x dx plus x dx. So when you add this 2, it would be 2x dx. It's a multiplication. So 2x dx, you can bring this dx to the other side. So dy by dx is equal to 2x. And this is the differentiation. This is the derivative. When you differentiate y with respect to x, you will get this one. So when y is equal, we have considered y is equal to x square. When you differentiate y with respect to x, you will get dy by dx is equal to 2x. Okay, let us check with some examples. Let us consider a square of side length 2 meter. So what will be the area for this square? Its area is equal to 2 square, which is 4. Okay, so I'm going to extend the length for 1 meter. So the change in length is 1 meter and change in area. So the total area is, the total length is 3 meter. So when you calculate the total area for this new square, it would be 3 square, which is 9. So now we can calculate what is the change in area. So small square, it is 4, and the big square, it is 9. So the change in area is 9 minus 4, which is 5. So total change in area is 5. Okay, so this is with a number, normal method. So let us use differential calculus to calculate the change in area. Okay, so now the same. Here we have considered a square of side length 2 meter and the change in length is 1 meter. Okay, so x value is 2 and dx value is 1. Length, change in length is 1 meter. So what if I substitute these values in the formula dy is equal to 2x dx. So let's substitute in The formula dy is equal to 2x dx, where x is equal to 2 and dx is equal to 1. So when you substitute the values, your answer is 4. dy is equal to 4. So when we use normal method, we are getting 5. But when we use differential calculus, we are getting 4. It's 20% error. But, so can we say that differential calculus is wrong? But actually it's not. Since we have taken the change in length as 1, we have got this much error. So let us reduce it. We have taken 1 meter, let us reduce to 0.5 meter. Now the change in length is 0.5 meter. What is the change in area in normal method? And let us calculate the change in area in differential method. So in normal method, the total length for a small square, it is 4. But for a big square, the total length is 2.5 meter. So when you calculate the area, it is 6.25. So when you calculate the change in area for both squares, it is 6.25 minus 4, which is 2.25. Same thing we can calculate using differential calculus. Here, the value of x is 2 and the change in length is 0.5 meter. So when you substitute those values in 2x dx, you are getting the value for dy as 2. Again, in normal method, we are getting 2.25. In differential, we are getting 2, which is 11% error. The error is reduced. Let us reduce some more values. So let us consider the change in length as 0.001 meter. So let us calculate the area for it. So change in area is 0.004001 for normal method. And when you calculate for using differential, the change in length dx value is 0.001 and x value is 2. When you substitute it, you will get 0.004, which is 0.024% error. So from this, what we can conclude, when you reduce the change in length, your accuracy is more. When dx value is infinitely small, which tends to 0, your accuracy is 0%. You will get the exact answer. So we would think that we can use normal method for all the problems. Why we need to use differential calculus? The derivative of the function y is equal to f of x is a measurement of how quickly the value of y changes with the change in the variable x. Instantaneous change. So this method is, we will use to monitor temperature changes, to calculate the distance or speed traveled, such as miles per hour or kilometers per hour, or temperature variance at every instant of second. Our stock market fluctuations throughout time can be used to forecast future stock market behavior. So for every instant, for every second, what is the changes? This can be calculated only using differential calculus. We cannot use normal method for this kind of changes. Wind, the direction of wind and the speed, it changes every second. So only using differential calculus, we can calculate the change in area or change in length, everything only using this calculus, not using normal method. So that's why we are using the differential calculus. So I hope everyone understood what is differentiation and why we are using it. So don't forget to subscribe our channel. And if you need any worksheets or PPT, you can log into www.abmaxsolutions.com. And if you have any doubts, you can comment your doubts. Thank you.